You can have as many elif statements as you want, which augurs for a certain type of structure that we'll look at. But again, you're controlling the flow, okay? And it's called a selection structure because of that. So the if is a keyword. And what else can I say about this? Elif is also a keyword, which is short for else if. And then else is also a keyword. Okay, and you got to have the colons at the end of each one of these keyword statements, or it won't work. Okay, so right here's some examples. Right, if you have a variable age and it has to have some value. If it's greater than 18, it'll print this out. Print, you may vote. Or you could have, you could extend that and have if else. If it's greater than or equal to 18, it prints you may vote. Or else, I should say, if you're not greater than or equal to 18, it prints that you're too young to vote. Or you could do something like this, and I believe we've seen one example like this already, where we're computing the discounts for wholesale customers. Notice the layering. Notice the order of these. If you change the order, if you have if invoice total is greater than 0 at top, this thing won't work, right? Because it will partition out, first of all, the ones that are greater than 500, and they get a 20% discount. If this is not true, if the invoice total is not greater than or equal to 500, then and only then will it test whether the invoice total is greater than or equal to 250, which of course implies that it's somewhere in between 500 and 250. So if it's in between 500 and 250, they get a 10% discount. Otherwise, if it's less than 250 but greater than 0, they don't get any discount. Okay, so if all of these conditions up here fail, then it prints invoice total must be greater than 0. This will always, either one of the ifs or one of the elifs will always execute as long as the invoice amount is greater than 0. Okay, so you're going to want to think about the order of these things. And this is pretty simple. And this slide just simply summarizes what we just said. I don't think we really have to belabor this. Again, the important thing is only one block of statements can be run each time an if statement is executed. Okay, so here's one for grading. And this slide 14.1, and there's a slide 14.2. And I think I jazzed it up just a little bit so you can actually input something. Right, again, notice the layering of this. You enter a score. There's a flaw here, of course. You enter a score, let's run it. Where I teach school, you can't get a score higher than 100, so it shouldn't work, but it does. But it just simply responds with, echoes back the score, and then it calls out which grade it is based on whether the score is in between 90 and 80, 80 and 70, 70 and 60, and so forth. Right, so do this again, we run the module, say the test score is 65, person gets a D. So that's what that one does. We also have, we have another one here, something like this. And this improves a bit on 14.1 in that, well, it doesn't really, it recognizes, we have compound statements here, and it's recognizing that grades are in these groupings, right? Greater than or equal to 90, less than or equal to 100, they get an A. The other one just simply said greater than 90, greater than equal to 80, 70, and so forth. However, this program is not foolproof either. If you run it the way it's expected to run, and you enter a valid test score like 85, it parrots back the grade. But on the other hand, if you enter a nonsensical score like we did with the previous program, in this case, you get an exception. You get a runtime error because you're trying to print out the grade and it's not defined. 110 doesn't fall into any one of these conditional statements. And so when you get down here trying to print out the grade, there is no grade assigned. So you get an error. Okay. But you get the same results with both of these two examples. The second one just simply using compound conditions where you have anded two conditions together. And again, with an and, they have to both be true in order for the entire compound expression to be true. So even after it evaluates scores greater than or equal to 90, and if that is true, it will still go over here and evaluate this as well, because again, and both need to be true for the entire expression to be true. Again, don't ignore the colons, and I'm the worst offender of this, leaving out colons, but it will remind you. Okay, so now, so which one should you use? Well, this one, the second example with the compound conditions, maybe makes it a little bit easier to understand. But on the other hand, another advantage is you could code these in any order. It wouldn't matter if you had the if for this one and all the other ones under elifs. Unlike the first program, if you mess up the order, it doesn't work right anymore. But so you might say, well, this is probably preferable. Well, it could be, but again, it's more code. Generally, less code is better. Of course, it's a balance, how much code and how elegant you want your program to be. Okay, so that's that. And again, when you start doing the compound expressions, they can be hard to understand, particularly when you're using nots. If you're using nots, ands, and ors all together, it gets kind of messy. Right, so you can use an if statement to validate the range of a score. And again, you need to initialize score to begin with. And so we do that with an input statement, and we nest that within an int to change the string into an integer, a whole number. And again, this will give you problems. It may work with a real number. Here, let's try this. Okay, so I've got this one somewhere. And way down here, enter test score. It's asking for an integer. Let's see what happens if I enter a real number. Yeah, it does. It blows up. Okay, so that's a problem by itself. And again, we're going to see many of the scripts that we play with today have these sorts of intrinsic problems. They don't do any data validation. But what happens here, of course, with slide 15 is we're using the what I call the incremental assignment. And what it does is it just, every time you enter a score, it adds that score to the total score, right? So here, let's get it to work. So if we...
Jeffrey?
Yes, sir.
Because we have actually taken the score as an integer.
Yes.
So it will not take any real value, will it?
No, you can't. You have to enter an integer. Is that what you're asking? You can't use it. Yeah, you can't use a real number. You get an error. But this will only run one time. Here, let's do it. Okay, so it initializes total score to 0. And then it's printing out, it says the test score, but it should say the total score. Take a look. No, it's just printing out the test score. That's all it does. Okay, so you have to run it again and again. And since we're only reporting the test score, this is kind of a clunky way to write this. You know, why initialize total score to 0 and then add the score to that? That seems kind of roundabout way, but it's just trying to demonstrate a very rudimentary form of data validation, right? If we enter a score that doesn't fall within the valid range, it simply gives you the error message. Okay, but the program then stops. Okay, so again, you're going to be using these data validation techniques for the exercise today. So here's another example, and we use customer type. Okay, so this is slide 16. It's asking for customer type to be either retail or wholesale. And it demonstrates the use of pass, and pass doesn't do anything. Okay. This if statement here just simply checks whether the customer type that was entered is either a lowercase r or lowercase w. And if it is, this pass causes the control to fall out of the loop altogether. So pass is a command that does pretty much what the name suggests. It's the opposite of continue. It causes the loop to end. Okay, but on the other hand, if the customer doesn't enter an R or W, it sets is valid to false, which isn't actually used in this program, but will be used in an extension of this that we'll see in a minute. Okay, so again, we're using compound condition to validate the data. And if it's valid, it just goes on its merry way throughout the rest of the program using the pass statement. You should avoid knots. We'll see an example of one, I think, shortly, and it's just, they're intrinsically confusing. Okay, because you've got a not. These statements work if the conditional statement is true, which means if you're using a not, it works if the conditional statement is not true, which gets messy. Okay, sometimes when you're using these layered approaches, it's a good idea to write out a table like this, sketch out some sort of a table to give you an idea how to do this. Okay, so this summarizes the discount rules that we will embed in Python code using nested if statements here.